On the dot. We live on the dot. We live on the dot. We are never late. The dot. So you know what's coming? You know the thing that we do? Share the live to your WhatsApp group, etc., etc. Let me share this live to some places, and then we'll begin. So as a comment drop on the dot. Yeah, we on the dot. We don't ever late, right? No guy is typically late, but you're always early. So look, as you come and share the live to your WhatsApp groups, to the various places. All right. Let me share this on Facebook. We are live. All right, let me drop this on WhatsApp as well. Let me send this in the groups. All right, so how we doing, folks? How we doing on YouTube? Everybody's going on YouTube. School, yeah, from y'all locked in for this exam. All right, 83 people on the live. Somebody's asking, where's my goat, Daniel? All right, so we had 83 people. Guyana 8:30 is 9:30. Yeah, but we always on time. Let the students here tell you if I'm ever late for class, they can count on the hands, or they can't even count on the amount of times, I'm late. Because I've never been late. All right, so we live on let me go live on TikTok as well, and then we'll drop in, we'll begin. So what do I need to change to go live? Show at least one camera before you go live. CSEC, math, revision. So today we're tackling arguably the hardest question in CSEC mathematics. Arguably the hardest topic in CSEC mathematics, which is it's probably measurement. Arguably the hardest topic because it requires lots of application. For those who are joining in, we're looking at some CSEC mathematics, share the live. So let's get started. So I think we're live on YouTube and TikTok. Good. All right, so let's confirm that y'all hear me both places. TikTok, YouTube, y'all hear me loud and clear. Let's confirm you hear me loud and clear on YouTube. TikTok, confirm that you hear me loud and clear. Then soon as that I get that confirmation, we'll begin. All right, so we at 160 on YouTube, which is good. All right, so we hear loud and clear. All right, any of my students on the live? Good. So TikTok here and loud and clear as well. We at 103 on TikTok and 161 on YouTube. Anyways, let's go. So today we're looking at some measurement questions, and I'm here with some of my. All right, I'm here with some of my students who will be with me throughout the entire life. These are all CSEC students in secondary schools, preparing for the exam just like you. So you will hear from them and probably they'll provide a student explanation. Well, you'll hear from them from time to time. We have Gabrielle, Kumisha, and Danielle, and Amor will join us just now. They're all from various secondary schools across the country. All right, I want to share all the information. So let's get started. We're looking at some measurement. Those of you that want to see the previous lives that we did, they're on YouTube. Let's go and search Liam Beaton, you'll find them. We are tackling all the various questions across the various topics. We looked at algebra first, then we looked at, measurement. Anyways, today we're looking at measurement. So let's go. First question. Keep in mind, these topics can be, some people may, say they're challenging, right? So, and they're very easy, but the application part is where the challenge would come in. So let's go. The first question says, in this question, take pi as 22/7. The diagram below shows a rectangular tank. For those of you that want to work along with us, I think this question is from 2021 January. So from 2021 January all the way to 2026. Hopefully we'll reach there. That is where we are working. So you can probably go to a past book and work along with us. So this question says, the diagram below shows a rectangular tank with base 50 cm by 40 cm that is used to store water. The tank is filled with water to a depth of 15 cm. So calculate the volume of water in the tank. So this one start off nice and easy. Some of these questions will be very easy. So this one start off nice and easy. Volume of water in the tank. So this is just as if you got a cuboid here. All I need to do is find the volume of a cuboid. It won't get much easier than that, eh? It won't get much easier than that. So volume here would be equal to length times width times height. And so the volume here, the length would be, you can say 40 cm times the width, which will be 50 cm, times the height of water in the tank, which would be 15 cm. And we punch this in a calculator nice and easy, and we get our 2 marks. Hopefully this year it will be just as easy as this. This will be 40 times 50 times 15. This will give us 30,000 cm cube. Right, hopefully this year we'll have a nice and easy question just as this, eh? Fingers crossed. How we looking, chat? How we looking? I can drop the answer before me, eh? I see the TikTok people are way ahead of the people on YouTube, or probably my comments on YouTube not loading. All right, so that was that. So make sure you put in units, etc. Don't give CXC. 2021. I think this is 2021, right? I think. So let's go. The next question says, the cylindrical container shown in the diagram below is used to fetch more water to fill the rectangular tank. The container, which is completely filled with water, has a radius of 20 cm and a height of 21 cm. So all the water in this container is added to the water in the rectangular tank. calculate the total volume of water that is now in the rectangular tank. So since you're early, let me ask hand over one of my students to um tackle this one and explain it. Who want to tackle this one? Putting all on the spot. Yeah, shy. All right, so early days. Hmm? Oh, oh, no. All right, so let's go. So this one says all the water in the container in this tank here is added to the rectangular tank. So you want to calculate the total volume of water that is now in the tank, the rectangular tank. So of course we got to find the volume of water in this tank here first of all. So to calculate the volume of water in this tank, it will simply be volume to formula to find volume of a cylinder. This will be given to you in the exam. It's simply pi r squared times the height. It's basically the area of the base times the height. So this will be pi, they said to use pi as 22 over 7. So this will be 22 over 7 times the radius, which is 20 cm, times its radius square. So we can say 20 cm by 20 cm, times the height, which is 21 cm. So I work this out. I like to punch in everything at the top in my calculator and then divide it by the bottom. So I'll say 22 times 20, 22 times 20 times 20 times 21. That would give me 184,800, and I divide this by 7. This will give me 26,400 cm cube. See, the thing is, when you see nice answers like these, nice whole number answers, you you could feel a little at ease. If you go and get a decimal, a big fancy decimal with a lot of recurring decimal, you don't feel nice. You feel as though you did something wrong. So when you get these nice whole numbers here, and you won't always be right, but most times, yeah. So to get the total volume of water in the tank, the total volume that is now in the rectangular tank, we know we have to add this volume here. So we can say 26,400 cm cube plus the water that we have above here, which is 30,000. So plus 30,000 cm cube. So when we add 30,000 to this, we'll get 56,400 cm cube. Nice and easy. All right, somebody's telling me I gave the wrong year. All right, so we looking. How we looking? How we looking, folks? So that's how we look at it. They are talking about why I'll join if I will speak.
Looking good, sir. Looking good.
All right, so folks, which one of these students here wants to work a question? They've been excited to join, eh? Are we looking YouTube? YouTube, do the hard ones. Now I'm doing see, there's the problem with students, You want to do the hard ones and the same easy ones you will get wrong, eh? Do the hard ones. We going through the line. When we reach the hard ones, we'll work the hard ones. So next one says, show the new depth of the water in the rectangular tank is 28.2 cm. So remember, we had the water in this tank, and we threw the water in this tank into this tank here. So they want us to show the new depth. And by depth, I mean when you talk about the depth of, in like, for example, in a pool, you're talking about the height that the water is in the pool. So they basically ask you to calculate when you finish showing the water. They want you to show that the new height of the water is whatever they give you. So to do that, all you need to do is use the volume that we have here, obviously. Use the formula and just find for the height. I think this question went for how many marks? 1 mark, 2 marks. So to do that, all we'll do, we will put on the formula, which is volume is equal to length times width times the height. So they want us to show that the height is equal to this. So we found the volume to be 56,400. So 56,400 cm cube is equal to, so now we just put in the other things. So let me go back. So the length will be the same. The length will be, the 40, and the width will be the 50. So this is equal to 40 cm times 50 cm times the height, which we want to show is 28.2. So as long as we work this out and we get 28.2, that means, we correct. So 40 times 50 will give us 2,000. So we can say 2,000 cm cube times the height is equal to 56,400 cm cube. So now we want to show that the height is this, so we'll just take over the 2,000 and it will divide. So we'll have 56,400 cm cube divided by 2,000 cm squared is equal to the height. So let's see if we divide this, if we get the magic number. So 56,400 divided by 2,000. Yeah, this will give us 28.2 cm, and the cm square will cancel out with 2 of the cm cube, so we left it cm. So it's equal to height. So we can say, QED. Can we show that the height is this, right? So the thing is, if you work this out and you get the height and you went and you show the height is this, that means everything else above, is correct. And you can leave the exam room smiling that you got all of these here correct. How are we looking, folks? Hi, is this what people doing CSEC maths? Yeah, yeah. Or anybody just interested that want to learn. How are we looking TikTok? How are we looking? No, I said good skills, sir, man. I'm assuming that person is from Linden that said good skills, sir, man. You're from Linden by chance? I know Linden, they like to say sir, man. How are we looking YouTube? Y square, sir? Down, but this square, cm times cm will give you cm square. I'm assuming that, right? So let's go. The vertical height of the rectangular tank is 48 cm. Determine how many more cylindrical containers of water must be poured into the rectangular tank for it to be completely filled. So the vertical height of the rectangular tank is 48 cm. So this is the full height. The full height of this tank, they're telling us, is 48 cm. So they want to know, how many more of this container we gotta pour. Yikes. How many more of this container we gotta pour inside to fill the tank? So of course, we have to find the total volume of the whole tank. Remember, for now, we're just finding for up to where the water level is. So we got to find the total volume of the tank. So let's find the total volume of the tank. So the total volume of the tank, so the volume is equal to length times width times height. So the length, I think the length is 40 and 50, and then the height would be 48. So the length will be 40 cm times the width, which is 50 cm, times the new height that they give us, which is 48 cm. This will give us the whole volume of the tank. Remember, we want to know how much more water we got to throw inside to get. So when we multiply all of this, 40 times 50 times 48, that would give us 96,000 cm cube. Now this here is the total water, total amount of water that can fill inside this container, that can fit inside. So to find the remaining now, so remember in total we have, how much water we got in this container? I think we found that earlier. So the total volume of water that we have in this container is 56,400. Because when we throw the water from here, we end up with 56,400. So the difference now, the difference, when we find the difference, that will give us the remaining of water, the remainder of water that is needed. So the remainder will be 96,000 cm cube. Subtract 56,400 cm cube. And when we work this out, this will give us a value of 39,600 cm cube. This is how much more water we need to throw inside to fill it. However, the question asks us, how many more cylindrical container of water must be poured inside? So to find this, this is the remainder of volume that is needed to fill the container. So to find how many of the cylindrical container we got to pour, we obviously have to, divide this by the volume of the cylindrical container, which we found to be, I think 26,400. So 26,400 cm cube. We divide this. Let's see if we get a nice number. Yeah, we get 1.5. So when we see a nice number like 1.5, we know that we looking good, right? So we can say 1.5 more will fill the container. And this went for a nice and easy 2 marks. How are you looking? How are we looking YouTube? All right, so I see somebody already got it. All right, nice. How are we looking TikTok? You looking good? Cooking with gas, well, it's a serious thing to cook with now, eh? If you cook with gas, it's something serious you cooking with. Don't cook out all though. All right, so let's continue. So that was I think this is either 2021 or January 2026. Either of the two. I don't know, I'm not sure. YouTube, what you are cooking with? I did this already. All right, let me carry on. All right, so I think I did this already as well. So let me do one that I did not do. I don't think I did this already. I know I did this one already. This one was you can find this on my YouTube. All right, let's still do it, man. This, nothing wrong with enough practice. So let's go. This one says Farmer Brown makes trough to feed his farm animals using wood that is 5 cm thick, as shown in the diagram below. The troughs are rectangular base, open at the top, and have external dimensions of 300 by 300 cm by 190 cm by 160 cm. Anybody want to tackle this? Show by calculation internal capacity volume of the trough is 8,091,000 cm cube. Anybody want to tackle this one? Eh, 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 the people are right. The people are walk of life. All right, let me. I guess this shy. All right, Daniel. So Daniel will take this one, folks. So all over to Daniel. The people
Oh,
love the people love Daniel.
okay. I see these values
So hold
correctly.
on, Daniel. Let me show Daniel some love in the chat, folks.
Huh?
Let me show
Again?
Daniel some love in the chat. Let
Okay,
me get some
pass.
fire. Let me get some fire for Daniel in the chat. Some fire emoji.
Chat.
Yeah, Daniel, go ahead.
It. Okay. Wait, should I read the big statement right up?
So read from show.
Okay. Show by calculation that the internal capacity or volume of the trough is 8,091,000 centimeters cubed. So this is a very fancy statement. First, I find the volume inside of this thing, right? So looking at this thing, we height, we length and we size, right? But we can't use it. The reason why is because we got walls. We want to count them wall them because we can't really put water in wall them. So we got to do now is to get the correct measurement. We need to subtract that the thickness of the wall from that 300 to get the width. So we see that have two walls and one wall is 5 centimeters. So in total we 10 centimeters for both of the walls. Yes, thank you. What is shade there? What is shade there? So 5 plus 5, 10, and 10 subtract 300. 10 subtract 300 is 290, right? Right, people? 290, right? Good. So we got the inside width. So now we need length. So again, same principle. Because it's two walls, we subtract 10 from the 190 centimeters, and that will give us 180. Okay. Now this height is a special case scenario. We ain't got no cover, so we can exclude the top. So only 5. So you'd have to subtract 5 from 160, and that would be 155. The height is 155.
So let me just pause, right? So the reason why we subtract that 155 is like if you got this phone and and this calculator is, let me say, 160 and this phone is 5 cm thick and we put, let me see if I can show it on the screen. It's kind of blurring. Anyways, you put the phone like right below. So remember the 5 cm already come out. So that's why we subtracting 5 cm alone. Can you see it on the screen? Anyways, yeah. Yeah, Daniel, well done, Daniel. Continue.
We have a C phone, we have a mind some business.
I just
Yes.
want this.
So now we can continue. We could use these new values. So now we get the values of inside of the drop. We can actually calculate the volume now. So volume is just the length times the width times the height. Multiplication is not cumulative, so you can just multiply them any way you want. You can multiply width by height by length. No matter what, you get the same answer. So we know that the length is 180 centimeters. The new width is 290 centimeters.
Well,
Sorry,
how
right
much is
here.
that? The length is what?
The new length is 180 centimeters.
Oh, 180, 180. Uh-huh.
Yeah. The new width is 190 centimeters times 190. 190.
190 to 90.
290.
Uh-huh.
And now the height is 155 centimeters. Yes. Now I'm picking up my phone. Now we doing this 180 times 290 times 155. And that is the same value that we get, which is 8,091,000 centimeters cube yeah, cube. Yeah, centimeters cube. That's the volume of this thing. Good.
Well done, Daniel. Well done. So that is how we show that, right? So, the thing you should love these show questions, eh? When a question says show, then you already know the answer that you're working towards, right? So well done, Daniel. Well done. So you already know what you're working towards. So the thing is, you gotta work smart with this thing, Even if you didn't had the application skills to know you gotta minus, think about, oh, they gave me this 5 cm thickness here by something I gotta do with this 5 cm thickness, to get this answer. Yeah,
So
right? Mm-hmm.
we got to right with it's a show, so they
Oh,
put
so
QED.
my bad, my bad.
We gotta look like we know what we're doing. We gotta look like high class
Yeah,
people.
yeah.
QED, the internal capacity is 8,091,000. Okay, good.
Good.
Very good.
So you put the QED so you can look a little bright. Anyways, well done, Danielle. Well done. How was that? How was that? That was good, right? So I don't understand the height. Why you're minusing 5 cm? People on TikTok will probably see. The people on TikTok will probably see. But when you got this thing, like, you can put this phone on top. You can put this phone on the side here. 5 cm cancel out from the height of this phone because, imagine nailing a piece of wood. I mean, you won't nail it like this. You can't nail it just resting on it. You gotta put it to the side and put the nail at the side. So that is why you're minusing the 5 cm. Right? Anyway, so let's go. Let's carry on. So that was that. So calculate the volume of wood that is needed to make the trough. Where's a trough though? Anybody can tell me where's a trough? Anybody know where's a trough? Y'all don't know agree? Y'all this life don't do agree? Somebody tell me where's a trough on YouTube or TikTok. Where's a trough? Anyways, it's really important. A drain kind of thing. Oh, let me see if it look like a drain kind of thing. Anyways, we can think. So calculate the volume of wood needed to make the trough. So the thing is, right? Remember this thing here is this thing here is like it hollow inside. It hollow inside. So if you want to find the amount of volume that is needed to make this trough, imagine as if you got like a rectangle like this, and you got another rectangle like inside here, and they tell you find the area of the shaded region, right? They tell you find the area of the shaded region. To find the area of the shaded region, you got to find the area of this outer piece, and then you find the area of this inner piece, and then you subtract the two area, and that will give you the area of the outline. So similarly, you need to do that with this trough, right? Similarly, you need to do this with the trough. So we already found the area of the internal piece. Now we got to find the area of the outer piece. So we got to use the outer measurement. So we can find the volume of the outer piece, not area, I meant volume. So the volume of the outer piece, length times width times height. So you can say 300 times 190 times 160. So it should be 300 is meters or cm? 300 cm, I think. It's cm, right? Yeah, 300 cm times 190 times 160 times 190 cm times 160. We multiply all this, we get 300 times 190 times 160. Yeah, because I guess syntax error, by. No, yeah, don't do like a video that I saw. All right, syntax error on the paper. Anyways, I got 9,120,000. So 9,120,000 cm cube. That is the volume of the outer piece. So to find the volume of wood needed to make this thing. So the volume of wood needed, it simply be the volume of, we minus the outer piece, which is this 9 million here, 9,120,000 cm cube, subtract the volume of the inner piece, which we found. Even if it didn't find the volume of this inner piece, the thing is, they already gave you it in this question. So even if you didn't find it, you could still get some marks here. So 8,91,000. So there's a minus, it will be 8,091,000 cm cube. I mean, work this out. We should get minus this 8,091,000 thousand. We should get 1,029,000 cm cube. All right, I see some people don't got in the chat. Let me big them up. Kumisha. All right. See, Ash. C Prasad sent what we need to do. All right. I see a fancy name got it as well. Nice, nice, nice. How we looking? How we looking YouTube? We beating this maths? Or the maths beating we? By the way, a new episode of Beating the Maths will come out at we'll be doing it at the new park, the Guyana China Park. Right? So yeah, I heard it for us on this live. So yeah, I must look out for me one day there. Sorry, no CXC number. All right, so this one. Farmer Brown must paint the internal surface of the trough. Given that 1 gallon of paint covers approximately 280,000 cm square, a surface determine the total amount of paint in liters that is needed to paint the internal surface of the trough. All right. So let me see. So we gotta know how much paint in liters we need. And this question went for 3 marks. All right. So internal surface. So now we're talking about covering the surface. All right. Now we're talking about covering the surface. So when we talk about covering the surface, now we move away from volume for a bit. And somebody tell me what we're talking about. If we're talking about covering the surface, what are we talking about? What we need to find now instead of volume. Let me see who will get it for us. All right, I see Marielle. Marielle has its surface area. Defining the surface area. So we got to find the surface area. The internal surface area. So you got to do some amount of work. So this is one thing you need to know about surface area. All right, so I'll find the surface area to the top here because of the nature of the question. So for surface area, regardless of the shape that you're given, when you want to find surface area, all you're doing is to find the area for each surface and then you add all together. So to find the surface area of this internal piece, we need to find the area of this shape here, 1, 2, we got an internal here, 1, 3, 4, and then we got one at the bottom, 5. So we got to find the area of 5 surfaces. All right, 5 surfaces is all we need to do. So, and then we'll use that answer to help us determine how much paint we need. So you can find the area of 1. So the area of 1, we see 1 and 3, same thing, right? So whatever area we find for 1, we just multiply that by 2 to give us the total area for those. So the length for 1 we see is 180. That's why I marked off here. And the width is 155. So we can say 180 cm times 155. This will give us 180 times 155. Where's my calculator? 180 times 155. This will give us 27,900 cm squared. All right, and we can multiply this by 2. So we can say the area of 1 and 3. So we just multiply this by 2 to get the total area for those. So we just multiply this answer by 2 and we'll get 55,800 because 1 and 3, they're the same shape, right? And then we can find the area of 4 and 2, 2 and 4. 2 and 4, so we know the length for 4 and 2 would be 290 cm multiplied by the width, which is 155. 290 times 155 cm, this will give us 290 times 155. This will give us 44,950 cm squared. And we know we multiply this by 2 to get the total area for those. This will give us 89,000 900 cm squared. All right, I see some people cooking. Some people beating it up. So this entire question is connected? Yeah, which is bad, eh? So now we got to find the area of 5. The area for 5, we know it's length times width again. So 5, the length will be 290 cm multiplied by the width, which will be 180 cm. So 290 times 180 will give us 52,200 cm squared. So let me drag all of this down now to the bottom so that I can continue working. Let me drag all this down to the bottom. I can continue working with the question. So that is that. So now I can find the total area. So the total surface area will be, all we need to do is add up 55,800 cm squared plus 89,900 cm squared plus 52,200 cm squared. I'm going to add all of this together. That should give me 197,900. All right, baby boss got it. And another person on YouTube trying to pronounce the name, but. So this here is the total. You see why this question is worth 3 marks? It's very simple, but you just need to do a lot of work. So this here is the total area that is needed to, the total surface area inside. So this is the amount of area you got to shade or paint. All right. So the next thing that we want is we got to find the amount of paint needed in liters. And it told us 1 gallon is equal to how much every liter. So the first thing we got to do, it told us that 1 gallon of paint can cover 280,000 cm squared. So to get this answer here, to get the amount of paint that we need in terms of gallon, we just divide this answer that we found here. We divide this here by 280,000 cm squared to get the amount of gallons of liter that we need. So we divide this by 280,000, and this will give us 0.707. We wrong it off correctly, 3 significant figures. So this is the amount of gallon that we can get from this here, but they want the answer in liters. So to end off it, we simply just multiply this here by the 3.79, and this will give us the amount of liters that we need. So 0.707 times 3.79, all right, will give us 2.68 liters. You round it off to 3 significant figures. 2.68 liters. All right, saw some persons already got it. Nice, nice, nice. So that was that. 3 marks. You see these 3 marks, they were very easy, just that you had to do some amount of work, eh? But they were very easy, eh? Very simple stuff. Just that you had to do some amount of work. If you work out this piece alone, at least you'll get some from the 3. And the thing initially, if you did not, the thing about this question, I don't really like it. Why I don't like the question is because, I mean, if I like it, that won't change the fact that it will come for CSEC. Eh? The reason why I don't like it is because if you got this first one incorrect, meaning you did not find these sides, you're doomed for the question. Everything else you do wrong, but you'll still get some marks if you work it out. So that's the reason why I don't like it. All right, so let's carry on. Anybody want to tackle this one? All right, so Komisha, read the question and then go ahead. So hold on, Komisha, hold on. So let me drop some fire emoji for Komisha. You drop some fire emoji for Kamisha. You drop some fire emoji for Kamisha. All right. Good. Yeah, Kamisha, go ahead. Somebody said this look like headache. I won't lie, it look like headache for truth. Yeah, Kamisha.
At a track meet, a cylindrical container fitted with a pipe, shown in the diagram below, is used to serve water to athletes. The cylindrical container of radius 12 cm and height 20 cm is completely cone-shaped cups, have a radius of 3 cm and a height of 8 cm. Calculate the volume of water in the cylindrical container in liters. Write your answer correct to 2 decimal places. So, to find volume of a cylinder, the formula is pi r square height, as we all know. So in this case, we'll use pi as 3.14 times the radius 12 cm times 12 cm times the height 20 cm, which will give us 9,043.2 cm cubed. Now we have to convert it into liters. So it will be, since we know it's 1,000 cm cubed equals to 1 liter, it will be the answer that we just got, 9,043.2 cm divided into 1,000 cm cubed. That will give us 9.04 liters.
So 432, and then we round the average volume is equal to 9.0. How much is it? 04?
Yes, sir.
04 liters, right?
Liters.
Good. How are we looking? How are we looking, chat? Well done, Kamisha. So the thing is, the question looked like headache, as somebody said, but it started off nice and easy. So please don't get carried away. Don't get carried away with the diagram. I mean, when I look at the diagram, I was like, right? But it's actually easy, eh? You see a pipe and you see running down, this look like headache, but as you see, all they simply ask you to do for us is find the volume of a cylinder. This is a glorified way of telling you that, right? Well done, Commissioner. Let me just drag this down. Great. Well done, well done. 3 marks this year. What? Wow. So 3 marks, folks. CXC was definitely kind this year. So next one says, how is it? No, this one look like some licks here, man. This one look like some licks, but let's see. Water flows from a cylindrical container along a pipe into the cone-shaped cups at a rate of 7.8 milliliters per second. Calculate the time taken to fill one of the empty cone-shaped cup. Give your answer correct to the nearest second. And it gave us the volume of a cone with radius r and height h. Its volume is equal to 1/3 of pi r squared h. So they want us to find the amount of time that it will take, and they want to round their answer to the nearest second, the amount of time that it will take to fill one of this cup here. All right. So the thing is, first thing we got to do is find the volume of the cup. That will give us the amount of water that can fill inside, this cylindrical, not cylindrical, this is a cone-shaped cup. So let me see, they give us the formula is 1/3 pi r squared. So the volume here is equal to 1/3 pi r squared h. So we find the volume of the cup first of all. Right? So the volume of the cup will be 1/3 times pi. Did they tell us what to use pi as? All right, they didn't tell us. Anyways, so 1/3 times 3.14 times the radius. They give us the radius as 3 cm. So it's radius squared, so it'll be 3 cm times 3 cm times the height of the cone, which is 8 cm. So I like to work out everything at the top. Work out everything at the top. So 3.14 times 3 times 3 times 8. This will give us 226.08. And I divide that by 3. That would give me a nice number by 75.36 cm cube. See, get a nice number like this, we know we're looking good, eh? So that is the volume of water that is needed to fill the cup. So now that we found the volume of water, now we can use that answer to find the amount of time it will take. So let's see what they told us about the time. They told us water flows from a cylindrical container at a rate of 7.8 milliliters per second. 7.8 milliliters per second. So what we need to do, we need to convert this here, because when you're given volume as in a cubic unit, we can convert that to liters, we can convert it to milliliters and so on. Volume can be converted from a solid something to liquid, right? So the thing is, when we want to convert to liters, we know we divide by 1,000. When we want to convert to milliliters, the same thing that it is in cm cube, it will be the same thing in milliliters. So this here, the volume here would be 75.36 milliliters. We don't do anything with it when it's milliliters. We don't need to divide by anything, multiply by anything. All right, that is one beauty with converting from cm cube to milliliters. Same thing. So now that we have the amount of milliliters of water that can fill inside this container, well, that can fit, that it will take to fill the container. Now we can simply use that and find the time that it will take. So every second we know 7.8 milliliters will go in the water. So to find the amount of time that it will take, all we simply need to do is divide our answer by this 7.8 milliliters. So we just divide this by 7.8 milliliters. And hence, we can't say we find in volume. So let me just here. So time will be 75.36 milliliters divided by 7.8 milliliters per second. So we divide this, we'll get 9.6615. And they said they wanted our answer to the nearest second. So 9.66 to the nearest second will be 10 seconds. So the time that it will take will be 10 seconds. All right, 10 seconds. Very easy stuff. All they asked us, all they did, they asked us in a glorified way, find the volume of the cone. In a very glorified way, find the volume of the cone, and then we simply just converted the volume of the cone to milliliters, and we just divided by 7.8 to get the amount of time. How are you looking, folks? How are you looking, YouTube? YouTube quiet by TikTok going on bad. YouTube, y'all don't allow TikTok to beat y'all, man. TikTok loud. YouTube, y'all gotta be louder than TikTok. How are you looking, YouTube? Very nice and easy stuff, right? So, reason why people call measurement, why people think measurement is so hard is because of the application. But really and truly, the working is very easy once you understand it, but it's just the application part you gotta get over, and measurement will be easy. And this was worth 3 marks. It's just the application part you gotta jump over, and the applications was beat everybody. All right. Somebody asks, do you have any donation platform? Any donation that you can do is subscribe, man. Subscribe and tell your friends and subscribe and share the video. That is how you donate. That's how you can
Sir,
donate. Yeah.
sir, if you want donations, I
Donate to
could,
me,
yeah,
You got
yeah.
like 4 students in class.
You see that all the time they quiet, now they hear the donation, everybody come alive.
No, sir, you worked my question just now.
Oh, my bad, my bad. Anyway, so yeah, that's all yeah, thing. Anyways, so let us do the last one. Archimedes, you want to work the last one? Sorry. Finish off and work the last one.
So the last question says determine the number of empty cone-shaped cups in B that can be completely filled from the cylindrical container. So basically we gotta find how many cups could fold that cone-shaped thing. So what we're gonna do, we're gonna divide the volume of cylinder by the volume of the cone.
So let me write the cylinder. So cylinder, the volume is 9,043.2 cm cube. Uh-huh. And the
And the
cone,
volume for the cone is 75.36. Now we divide them.
so 9,043.2 cm cube divided by 75.36 cm cube. Uh-huh.
We will get a nice number of 120 cups.
For 3 marks. Right? 120 cups. See when you get a nice number there. If you had, you see the thing is if you work this out and you get an answer like, I don't know, 78.32197, and they did not tell you at any part to round off, know that you do something wrong, eh? If they did, a good tip, if they don't tell you to round off your answer to something and you get a fancy answer, think twice about your answer, right? Think twice. Think twice about your answer. Somebody say if you want to donate, you could donate in gas. We got what we gotta do. We gotta cook with gas. We can't donate with gas. We can't drive with gas now. You know why? You know why Guyana got a gas shortage? Well, me know if we got gas shortage, well, around the world. You know why? Because everybody on this life cooking with gas. That's why all the gas done.
We not only take gas, we take other stuff.
Okay. Anyways, so this question here that had the big debate, eh? So by the way, let me just tell, yeah, we're right. The people on here, I was wrong. So Christian, you want to tackle this one? You want to tackle the first one? Read it and then go ahead. So now we hear from Christian.
Okay, sir. The diagram below shows a solid made from a semicircular cylinder base with a rectangular prism above it. The diameter of the
Cylindrical. Cylindrical.
cylindrical base and the width of the rectangular prism are 4 cm each. Calculate the total surface area of the solid. The surface area A
Hold
of
on, hold
a
on. Stop, Christian. Oh my bad. Christian, was it? Christian, yeah, drop some fire for Christian. Oh my. Can't do Christian like that. Christian can't start without getting some fire. Oh my bad.
sorry, don't start already though.
You drop some fire for Christian. Yeah. All of these persons you see here are persons sitting the exam, eh? Yeah, Christian.
So we have to the formula, not the formula, the area of the semicircle is bracket half bracket 2 pi r square plus 2 pi r h. Right, is it wrong? Nope.
So So the
Sir,
surface, so we find the total surface area of the solid, eh? So so we find it for Christian, we find it for this area, the surface area for this piece here.
yes, sir.
So they give us this surface area for a cylinder, a normal cylinder. Remember, this is half of a cylinder. So I'm just explaining why she did the half, eh? This is half of a cylinder, so we just half the formula that they give us. They gave us the formula for the whole cylinder. So we just half the formula they gave us, right? Anyways, continue. So area is half, 2 times,
2 times pi,
what is pi?
which is 3 or 22/7. 3 point
22/7,
yeah, times the radius.
What is the radius?
The radius will be, so that is 4. Sorry, I got divided by 2
So the whole
because
thing
the
is
length is
4.
4.
So half of it will be 2, right? Good. The radius
Yes,
is
sir.
2, is a
Plus,
cm,
yeah,
times 2 cm in the square plus
pi 22/7
2 by 22/7.
times 2 cm times the height, which is 4
I see.
cm.
The height would be from the start of this thing to the end, right? That is the height. So no matter, it doesn't look as though it's is that the height of the shape, but the height is out from the front part of the cylinder to the end, right? From the front to the back. That is the height. So the height would be 12 cm. Right? So it'd be
Okay.
12 cm. Good.
So by multiplying all of this, I put it into my calculator
Mm-hmm.
and I got 176.
They multiply everything here.
Yes, sir.
176 cm squared. You multiply by half already too.
No, sir. So when you multiply by half, we'll get 880 cm square.
So let me do this maths quick. So let me do this quick. So 2 times 22 times 2 times 2 will give us 176 divided by 7 will give us 25.14. Let me just do that. 24.14 plus, work with this piece now. 2 times 22 times 2 times 12 will give us 1,000, and that divided by 7 would give us 150.86. And then when we add up all this together, 25.14 plus 150.86 will give us one. Yeah, Christian, you're right. Half times 176. And I have this to get
Sir, I got 88.
88, right? So 88 cm squared, eh?
Yes.
So the area for this piece here is 88. So we don't find the area for this whole thing. So we can say this piece is 88 cm squared. So total surface area, as I said earlier, you just find the area for all these surfaces. So now we gotta do some big fancy work. Find the area for all of these surfaces. Yeah, Christian. So let me work to the top here now. By the way, I can drop your answer in the chat if you already finished it, eh? Yeah, Christian, go ahead.
Sir, for the surface area, we recommend you write the square first, which is area times length times
This piece
width.
is how much?
Yes, sir.
All right, so as you work, I'll highlight it, right? So we find it for this piece. So the area for that piece is, so we can just say 4 cm times 4 cm, which we get, what we get?
cm.
16 cm squared. Good. So we can just multiply that by 2, because those two are the same, right? So we can just multiply this by 2. So the area for those two pieces would be 32 cm squared. Yeah, Christian, continue.
And now we'll find for the rectangle.
Just this piece here.
And the area for the rectangle is length times width.
So we can do 12 cm times. And what is it width?
4 cm.
4 cm. So the area will be 12 fours.
12 times 48, sir.
48.
Cm square.
So you're saying, folks, surface area, you're just finding the area for all these surfaces, right? So surface
Sir,
area is some tedious work.
and now we multiply by 2.
Yeah, you multiply by 2 to find this back piece as well, right? So we just multiply this by 2 to find for the include the back piece. So this will be
96 cm square. So now for the total surface area, we have to add up all of these
anything
surface
missing?
area. Wait,
We forget a piece.
okay.
Oh, Mr. Daniel. Oh, we missing any surface? So I think because we highlighted, we missing a piece, right? Remember we found the area for this piece here, this curve piece, and then we find the area for all the sides. Let me see. Somebody tell me what missing in the chat. Which one missing? Which side missing, chat? Let me see. Two surfaces missing. Semi-star. No, we already found for this whole piece at the bottom here. So let me choose another highlighter. Let me use a blue. The bottom one. Yeah, so the bottom piece missing, right? So the bottom piece missing. So we gotta find for this piece here.
Sir, will that be like the same measurement as the rectangle?
Which one?
The bottom piece that we have to find.
Yeah. Would it be the same? Is it 4? Yeah, it will be the same. So all right, so let me hear. Continue. My bad. So let's see. So let's find the total surface area now. Let me see what Christian will do. Go ahead.
Sir, I have the total surface area of all the sides is 88 cm square
Mm-hmm.
plus 32 cm square plus 96 cm square
Mm-hmm.
and plus 96 cm square. Because the bottom piece.
The bottom and the top.
Yeah, the part that you highlight.
And this top piece there. Did we find for this top piece too?
No, because we already multiplied it.
Or the
Right.
multiple? Yeah. So this will give us a total area of
312 cm square.
You might have got this on the chat. So we regard the 88. From the 88 is the first one that we found, right? 88 is the first one. 88 is this bottom piece here. And then we found the area for all the sides. And the thing is, the top area, this top piece here, is the same thing as this 96. So we just how we do we use this 96. We use back this 96 twice. Because it's 12 times 4. Right? 12 times 4. So 12 times 4 at the bottom and 12 times 4 at the top. So there's how we got that. So we had to add these, we had to get in these two sides, the top piece and the bottom piece. Anyway, so let's go. See that one, calculate the volume of the solid. So the volume of the solid now. All right, let me work this one. So the volume of the solid will simply be, let me just erase everything now. The volume of the solid will simply be the volume of this half of the cylinder at the top plus the volume of this top piece here. So let me find the volume of this cylinder. So this is half of a cylinder, right? So I can say volume is equal to, I know the formula for a cylinder, it's pi r squared h. So the volume will be pi, which we're using all the time as well. We're using as pi, 22/7. So 22/7 times the radius, which we found to be 2. So 2 cm times 2 cm times the height, which we found to be 12 cm. So the volume of the cylinder, multiply everything at the top. Or check your comments. So it's supposed to be 48/4. Yeah, so if you do 48/4, since we have 4 triangles, it's the same thing as 96 plus 96, right? 96 plus 96 is 192, and you do 48/4. You can say 192, eh? All right, Kizia. Anyways, so let's go. Let's deal with the volume. So when it 2 times 2 times 2 times 12 will give us 1056 divided by 7, which will give us 150.86 cm cube. That is the volume of this. No, that is not the volume of that piece. That is the volume of a whole cylinder. So remember, it's half of a cylinder, so we need to divide this by 2. So the volume will be, we divide our answer by 2. So 150.86 divided by 2 will give us 75.43 cm squared. So that is the volume of the bottom piece. So now we just find the volume of the top piece and the total volume of the shape. We just add all together. So the volume will be length times width times the height. We find it for this top piece now. So the volume will be, the length would be 12 cm times the width, which will be 4 cm times the height, which will be 4 cm as well. So this will be 12 times 4 times 4, which will give us 192 cm cube. So the total volume will then be, so let me drag this at the bottom to finish off this question. So the total volume of this fancy shape will simply be, the volume will be 75.43 cm cube plus 192 cm cube. And this will give us So 192 plus 75.43. I would round off and give us a nice 267.43 cm cube as the volume. All right. How are we looking, folks? How are we looking, TikTok? How are we looking, YouTube? Are we cooking? We cooking with gas? Tired? Can't tired. How long more we got? How long more until so right now I ain't got gas. Well, now you alone. Anyway, so let's go. Let's press on. Let's carry on. So the next one says the solid is made from gold. 1 cubic centimeter of gold has a mass of 19.3 grams. The cost of 1 gram of gold is $42.62. Calculate the cost of the gold used to make the solid. So we got this here is the volume, and they said the whole solid is made out of gold. So if the whole thing is made out of gold, and they're saying 1 cubic centimeter has a mass of 19.3 grams. So we need to find how many grams inside of this gold. Well, inside of this container. Not container. How much grams this thing is we can get from this volume here. So the amount of grams will simply be, so we found the volume to be 267.43 cm cube, and we multiply that by every 1 cubic centimeter. It give us 19.3, so we multiply this here by 19.3 grams. Hence, this will give us, we work out this 19.3. This should give us 5,161.3399 grams, eh? So that is the amount of grams we have there. Now you gotta find how much gold, how much money we can, how much money this thing will cost. So the total cost will be this answer that we have at the top here, 5,161.399 multiplied by, because for every 1 gram, it's $42. So this will give us 42 times 42.62. 42.62. This here will give us 219,978 point, around after 2 decimal place, 83. Chiching money.
Excuse me, sir. The live on TikTok, it's really blurry and you could barely see anything.
Truth.
Yeah.
The live is blurry on TikTok.
Yeah, I just logged in and see.
Somebody said it's seeing good. Or, Kamisha, sure it's not your internet? Because I'm seeing the live right now, right?
A few persons in the comments said it's blurry.
All right, so people saying they're seeing good. Kamisha, internet you're using?
I using two different kind of internet, sir.
Okay. So we have Amber is in the chat, folks. Amber is with us. The youngest and the baddest. Y'all know that all right, so I see as well I gotta block some people from TikTok. Right. Or edit your name or something, man. Oh my. No, yeah, but yeah, I got these fancy names. All right, so let's carry on. So we wrap up just now. Let me see. I don't want us to go too late tomorrow's school. So we do one more question and we call it George. Anybody want to tackle this one? Let me give you all the time. All right, Lalchan is Lalchan.
Me. Thank you very much. Thank you very much.
Go ahead,
So,
Lalchan.
so this will remind me of something. Hmm?
This here?
Yeah, this will remind me
What it
of
remind me
something.
of? Remind me of
Hmm?
let me hear what does it remind you of, Daniel?
When you get a record passes,
It
education
reminds me of
officer.
it too.
Yeah, so yeah. Those of you that don't know, I'm one of the fastest educators in Guyana. Not one of the fastest, the fastest. In Guyana, some people would argue in the Caribbean, some people would even go as far and say worldwide. Anyways, go
Okay,
ahead, Daniel.
okay. So you need to find it. Show that the total length of the running track is
Read the thing, the man.
350.
Oh, read the question, huh?
Oh my guy. Use in this question, use pi as 22 over 7 full stop. The diagram below shows a scaled drawing of a running track. It consists of a rectangle and two semicircles with diameters Ln and MP. Ln is equal to MP is equal to 9 meters and Lm is equal to NP, which is 98 meters, right?
Pause, Daniel.
Yeah, what do?
Yeah, yes, this one is the comment on TikTok. What Sarfraz is saying is true. Bold record wouldn't be safe for a very long time, right? It won't be safe if I continue. But I retire. This guy end off on a high. So I retired from the track. Ever since that one race, that was enough. Sorry, Daniel, back to you.
No, we could pay you for come back.
If I
Yeah,
know I get a grade one, I'll come back.
of
Don't
course,
collect
start
donations too.
preparing.
We're collecting donations too.
Start preparing. Can we do this? Come. So yes, can show that the total length of the running track is 350 meters. So it's in a really got no formula to calculate the entire thing, so we could break it up into smaller pieces, right? ICCXC do ICCXC do that very nicely for we. We get the big rectangle in the middle and two semicircles on the sides, right? Yes, yes. So now that line on the outside is where you're running, right? So we're trying to find the length of that thing, right? So if we know that in the statement it's a LM is equal to NP. So we know that top sections are that between L and M is also 98 meters are. Could write it in. Very good. Good. So now we gotta find these two semicircles. So you gotta use the imagination, right? If you take away this rectangle, right, it's from one big circle, right? So we just use the formula for circumference of a circle, which is pi d or 2 pi r. In this case, we can use pi d because we got the diameter already. So the diameter with
Pi
pi d.
d, or you can
Yeah.
say 2 pi r, right? Good. Yeah.
We ain't really want to complicate with life, so pi d.
All right, pi d.
So we know the diameter is 49 meters, which is indicated in Ln. So it would be 49 times 29 meters times, or I could do 20 over 7. Yeah. Anyway, over 7 times 49, right? Now, for people I know, some people struggle with this. So you could write this thing back as, one big line and 22 times 49 over 7, right? Just to simplify, right? So now we use a beautiful tool that God gave we, which is the calculator. So 22 times 49, that is 1078 over 7, 1078 over 7. And now we divide this by 7. And we get 154.
Yeah, Daniel.
154.
So tell us about this 154 and get this 154. How you feel?
Oh, so
Yeah, nice whole
what
number.
we feeling good is a whole number thing and no fancy point them. Yeah,
Yeah.
good. So there's the distance of those two circular sides. So remember we got the distance of those two straights, which is 98. So we gotta add those two 98s together, and then what we get in with 98 times 2, that's 196. So 154 plus 196. Anywhere around 98 plus 154. And that gives us 350 meters. And let's go
Right.
to the next one. Come.
So show question, the show question, we all love a show question, right? We all love a show question because we know we're working towards, right? We all love a show question. So when you see show in the exam, smile, because if you. All right, Daniel.
Okay. So Nathan walks a constant rate of 1.4 meters per second. Calculate the time it takes him to walk 7 laps around the track, right? So first things first, we gotta find what is 7 laps, right? What distance is 7 laps, right? So for do that, we can take the total distance, which is 350 meters. So 350 meters times 7, which is 2,050, 2,450, 450, yes, meters. So now in some questions, what I like to do is, if you can't remember what to do next, look at the units. It's a meters per a second, right? So every 1.4 meters is 1 second. And we're trying to find the time, right? So we know we gotta divide 2,450 by 1.4 meters per second, right? Add line 1.4 meters per second. Very good, very good, very good. So if you look at the meters, you would see that the meters is cancel out to form seconds. That's a good indicator that you're doing the right thing. So 2,450 divided by 1.4, that is 1,750 seconds, because remember meters are cancel out. So it takes him that amount of time. Yes, Amber want to take the next one because I remember she did.
Let me
Would
let
you
me finish
like?
up. No, yeah, Daniel, you finish up this one.
Okay, let
I'll
me
take
check
the
my
last one,
note.
right?
Okay, Tafari, this fancy name. Tafari runs 1 lap of the track in 68 seconds. Determine the number of laps Tafari can complete in 1 hour, right? So, okay. So first of all, we gotta find what's 1 hour, right? How much seconds are in 1 hour? So we could break this thing down, right? We know that 60 minutes are in an hour. And we know that 60 seconds are in 1 minute. So you can multiply 60 by 60. Yeah, write it down. 1 minute is equal to 6 seconds. Yeah. So now 60 times 60. Oh, wait. 60 times 60 is equal to 3,600. So in total, 1 hour is 3,600 seconds, right? So now we know how much, we know that 1 lap is 68 seconds, right? So to find how much laps we can do in 1 hour, we just divide 3,600 by the 68. And now this is equal to 52.9. Wait, 52.9, right? Now, you could run CXE, those got the policies and three significant figures. So we just leave it as three significant figures. Right, sir? Just leave it there.
So the thing is, right,
Mm-hmm.
they want to know how many laps he could run in this time,
Ooh.
right? One
Oh
hour.
yeah,
One.
round it. You got round it. You got
No,
round
we
it.
can't wrong it. Remember,
You
he
can't.
finished the lap. In this case, here we
Ooh.
gotta use some common sense here. Because remember,
Mm-hmm.
if you run 52 laps and then he run piece of the other lap, he didn't finish the other lap. So we can say in this case, he run 52 laps. We're not really wrong enough. We just say that he run 52 laps because they think I'm not like a 52.9 lap. Just go, we think I'm not like a 52.9 person. It's 52. So in this case, you can say he ran 52 laps, right? Because we can't, like a point 9 lap.
Never know, sir. Never know.
Well
And
done,
do
Daniel.
the
I'll give Daniel some fire.
and donations.
That's relax. So, hey, yeah, look, I'm not gonna bring back yeah, you know, yeah.
No, 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 no. You want me back to count?
We still have to be back one more time, I guess.
Yes.
We can come
Yes.
like
What?
we can come back like 2 more times.
Three.
Sorry,
lovely,
2 or 3 more times.
amazing,
I got the
amazing,
Very
exams too,
good.
you know.
amazing.
I got the exams. I know we make you fall in love with maths, right? I make you fall in love with the maths, but yeah, yeah, the exam. Anyway, so let's do the last
But
one. Now this
sir,
last one, and then we can hear from Daniel and Kumisha and Christian and
oh,
all right. So this last one now. This last one, I can remember this last one. This one caused a lot of problems when when it came. I can't remember which year exactly, but I can remember everybody was abusing bad. Oh God, the question 3 marks, yada yada yada, blah blah blah. Anyway, so the question says, Nathan completes running 1 lap of the track every 72 seconds. Tafari and Nathan start running at the same time from point L on the track. Each completed a number of laps on the track. Calculate the least number of laps that each will complete before they are both at point L again at the same time. So this one caused a lot of problems, right? Whatever year it came, it caused a lot of problems. I think it's probably between 2022 or 2023, around there, or 2024, somewhere around there, right? This one caused a lot of problems. Anybody that wrote maths this year can, yeah. Anyway, so they want us to complete this statement. Tafari completes X amount of laps and Nathan completes whatever amount of laps for them to meet up back at the same time. So this is basically a fancy way of asking you to find um the LCM, right? A fancy way of asking you to find the LCM, right? This one is a fancy way of asking you to find the LCM. Now this is where the licks came in this year. Um so we see Nathan ran 72 laps. All right, Nathan ran 72 laps, and Tafari, fancy name, Tafari ran how many laps? Sorry, what was I saying? Nathan completes 1 lap in 72 seconds, and Tafari, how long Tafari took? Tafari ran 1 lap in 68 seconds, right? So Nathan ran 1 lap in 72 seconds, Tafari ran 1 lap in 68 seconds. So we want to know when they will meet up back again. Can you remember Nathan is way in front of Tafari. So it's like you got this thing here. They start off at this point. Nathan gone around. I should do Tafari. Tafari gone around in 68 seconds. And in 68 seconds, Nathan probably there's somewhere like here. And then Tafari gone around again in another 68 seconds. And so you want to know when they're gonna meet up back again. So it's a glorified way of finding the lowest common multiple that will help us, when they will meet up. At what second will they meet up back again at the starting point? All right, so try to imagine that piece of running in your mind. So we gotta find the LCM. Now, this is why this causes a lot of problem. Now, there's a thing that we can use to find the LCM that is called prime factorization. That will always help us to find the LCM. So prime factorization basically tells us, we split this 72 into prime numbers. We can multiply a whole heap of prime numbers to get back 72. So we first start off by splitting the 72 into two, a prime number on one side and any other number on the other side. So we know we can multiply 2 by, let me see, 72 divided by 2. If we can multiply 2 by 36 to give us 72. So we can split the 72 into 2 times 36. And since this is already a prime number, we stop there. So we can break down the 36 as well. We can break it down into 2 and 18. We can break down the 18 by 2 and 9. And we can break down the 9 by 3 and 3. So we can express 72 as 2 times 2 times 2 times 3 times 3. This will help us to find the LCM. And we can do the same thing for 68. We can break down 68 into 2 and let me see, 68 divided by 2. 34. We can break down 10 to the 4 by 2 and 17. And I know we can't break down that further, so we can express 68 as 2 times 72 times 17. So now this is how we can find the LCM. This is how we use all this fancy thing to find the LCM. This is an easy way. I mean, you can do trial and error, try until you get it. That is another way you can do it as well, or you can, tackle it like this. So this is how we can find the LCM. All right. So what we basically do, we take all of the numbers, we take the highest powers from each of them. So for example, we got 2 and 2 here, and we got 2 and 2 times 2 times 2. We take the highest one. So we can take the 2 times 2 times the 2. Then we got the 3 times 3. So we add on the 3 times the 3. And then we put back the 17 times the 17. And this will, when we multiply all this will give us the LCM. So 2 times 2 times 2 times 3 times 3 times 17 will give us an LCM of 1,224. So this is one way we can find the LCM, or you can just find the LCM by doing some trial and error. Let me see. 72 times 68, that would give us that. What I used to do in primary school, what I used to do in secondary school to find the LCM, all I used to do is multiply the two numbers together, and then I just keep dividing them by 2 to get the LCM. I divide this answer that I got by 2. I'll get that, and then I see if both numbers can go into them, and then I divide by 2 again, and I see if both numbers can go into them, and that is what I used to do, right? So you can also try that method as well, right? That's what I used to do. Just multiply the two numbers and then just keep dividing by 2 until you find the lowest number. Anyways, so this is another way you can find it though. This is a cleaner way, a faster way. So at 1,224 seconds, Nathan and Tafari will meet up back together. So now we gotta find how many laps they run when they meet up back together. So we know for Nathan, he ran 72 seconds for every lap. So Nathan, to find the amount of laps that he ran when he ran for 1,224 seconds, it will be 1,224 divided by 72. And when we divide this by 72, we saw that Nathan ran 17 laps. And then we do the same thing for Tafari. So Tafari, she ran every lap 68 seconds. So we do 1,224 divided by 68. And I think this will give us 18, I think. And we divide this to get 18. So Tafari completes 18 laps and Nathan completes 17 laps, and then they will meet up back together. All right. So yeah, that is how we can work this out. For us to find the LCM of 72 and 68, that will give us the time that they will meet up back together. And you divide that to get the amount of laps. Charles.
Hi, sir. So I thought we were gonna do the next question. So I purposefully didn't do anything else. So I was wondering if you could do the first question from the next number 6, please.
All right, so let me give Amber. Amber wants to tackle one. So tackle this one, Amber. Last one for the night. Read it and answer it.
In this question, from the top or just
Yeah, read everything.
okay. In this
Hold
question,
on, Amber. So before Amber begins, let's give Amber some fire emoji. This is Amber some fire to encourage her. Amber is the youngest and the baddest. Go ahead, Amber, go ahead.
okay, so in this question, take pi to be 22/7 and the volume V of a cone with radius r and h as V equals 1/3 pi r square h. I don't have my glasses tonight, so if I skip over something, please bear with me because I don't have my glasses. So the diagram below shows a sector OMRN of a circle with center 0. I think it's
Center
0, yeah.
O. Center O, right? Center O.
Oh,
Mhm.
radius 12 cm and a sector angle of 186 degrees,
68.
which was 168 degrees, which was formed using a thin sheet of metal. Calculate the perimeter of the sector above made from the thin sheet of metal. So to calculate arc length, to find the arc length, the formula is theta over 360 times 2 pi r. So you put theta, which is 168 over 360, times 2 times 22 over 7, which is the pi that they told you to use, times 12, which is the radius. So now for me, what I do is I just cancel the 7 because it makes things kind of easier. So you get 1 over 15 times 2 times 22 times 12 equals 528 over 15. So you just divide that and you get 35.2 cm.
When we divide all this, you get 35.2.
Yes, sir.
All right. CM. All right.
cm. And now you add the two radii. So 12 plus 12 equals 24 cm.
Just so, let me just check this thing. Yeah, Amber is correct. Excellent. So this will give us the arc length, which is 35.2. Yeah.
And the reason that we add in the two radii is because the perimeter includes the two straight lines. Because we know perimeter is basically the length around the shape, which is a sector. So you add 12 plus 12, you get 24 cm. And for your total perimeter, to finish the question, you just add the two and you're gonna get 59.2.
All right.
Yeah, 59.2.
Yeah, I
Thank
can
you.
see this question went for 3 marks, right? Excellently done, Amber. Yeah, perimeter is the total distance around. So if ours got to find the arc length, as Amber rightfully said, and then you just add that to the two radii. Well done, Amber. Well done to all of you. So that was the perimeter. So that was that for measurement for tonight. We touched on showing, a lot of showing. We touched, anybody was here from since the beginning? Anybody was here since the beginning? Everybody that was here since the beginning, drop a comment on YouTube and TikTok. Let me see. Identify yourself. Let me shout you out. Bill, all right. Big up yourself. Nice, nice, nice. Grade one to everybody. You get a grade one. You get a grade one. I went since the beginning. You get a grade one. You get a grade one. You get a grade one. Somebody named Dry Bread. No, I can't. What's the way with y'all, students? Why would you name yourself Dry Bread? Why did you log down on TikTok and when it's say put in first name, dry, last name, bread. Anyways, everybody was young. I mean, I never passed through that phase, but what you gonna do? When I was young, we used to put young in front of your name, like Leon Young. Young. I won't tell you why what I was named. Anyways, so that was the end of this live. I trust that this live was helpful for you. You work some measurement questions. As we saw, the measurement questions, although they may be challenging, the hardest part is within the application part of it. You just need to read the question carefully. All they will ask you to do is find area, total surface area, volume, convert volume to liters or milliliters, find area of sector, area of circle, perimeter of a sector. Same thing. They just ask you those things in glorified ways, eh? And now see, oh yeah. So yeah, take care. We'll see you back another time. We will discuss when we'll come back again. So that's why I want to come back.
We could come back anytime, anytime,
Anytime.
Mhm.
anytime.
Anyways. So yeah, I give I give all four of these students. I give them I give them a big round of applause. It's not easy. It's not easy as a student to come live on TikTok and Facebook, not Facebook, YouTube. It's not easy, right? I could not have done this when I was their age, right? So that was very brave of them. You have to know what you're doing, and also you have to be very brave to come, as you know. So kudos to y'all, right? Anyways, I'll see y'all back in the next live. Y'all follow us on TikTok, and by us I mean me, so that you will be up to date when we'll come live again. And yeah, best of wishes in the exam. See y'all again. All right.
Don't just scroll on TikTok for hours. Pick up your book and work.
Okay. Message
Your
from
maths.
Kalisha. Pick up your book and work. All right, so we still live on YouTube. Let me go and end.